I'm not here for super high quality recordings. I'm logged into work right now. I work at Wells Fargo as a software engineer, and I'm logged in. My PR recently got merged. Thank God. That PR was open way too long. I had to go back and forth with my coworker about the solution, but it's a team sport, so you can't run a play without consulting the quarterback. You know what I mean? Anyway, I fucked up. Yeah, so I wrote a solution. This works for quite a few of these, but it doesn't work in the case where there's more than if the string has more than one of a character in the pattern. So basically, we're not checking that there is only, to put it simply, we're not checking properly that the pattern or a permutation of the pattern exists in the string. What am I talking about? Well, for these other cases, we are not checking that since there's not multiple B's and not multiple C's and A's. Let's say, for example, I put this B in here. Technically speaking, the B is in, the B is in, the C is in. Now, according to our solution, that would put our pointer up to 3. The length of the pattern is 3. That making sense? So, yes, we saw a B, we saw a B, we saw a C, which are all in the pattern, but we didn't see A. We didn't really see the pattern, so the pointer stopped here. B to C. And I know it's really small on the screen, but it's not for an audience. It's for me to watch back later. So yeah, I fucked up there. So I just grabbed the solution from here. I'm taking a look at it. So they're using a frequency tracker. They have a start. They have a matched. And what are they doing? Well, they're looping over the string. They're adding a count. Oh, so they're first adding the count of each character to a dictionary that tracks the number of occurrences, right? Then they're saying, cool, create our window. Our goal is to match all characters from the goal is to match all the characters in the frequency with the string. So our goal is to try to extend this window. The right character is this. If the right character is in our frequency, subtract it at 1. If it's at 0, so the point is to say we matched it if we've seen all of its occurrences. That's the only way it's been matched. So if at this point matched equals return true. Otherwise, if the window end greater than or equal to the length of the pattern minus 1, and the left character is the start, move the start. Huh? What? I don't understand. If the index that holds the end of our window is greater than or equal than the pattern, then we need to reset. Because then we say window start plus 1. If left character in, if left character in that equals 0, then take our match down to 1. Crazy. What? I have to see this in person. How do I see this? How do I? Is my hat tight or am I feeling this energy drink? I'm feeling a little charged up right now. What's going on? All right. So we have a window. We have some random characters: A, B, C, D, E, F, G. It says if our window end is greater than the length of the pattern, our start is going to move. Let's look at this first chunk. What does this mean? Why would you bump up the window if your window end is greater than the length of pattern. Oh, because we can only look at, oh. All right. So in the example, I'll try to write it on the screen this time, so I can actually go back and see what I'm writing. So in this example, right, if we have A, B, C, D, E, F, G, and our pattern is the AB. What they're saying is, if our pattern length, right, I'll say length of AB equals 2, right? I did better equals on there. Length of AB equals 2. And they're saying that if our index gets to, if our index okay, I wrote the indexes down below. So it's saying if our end pointer is greater than or equal to the length of AB, or our pattern, I should say, minus 1. So the length of this is 2. So it's an offset. Why is it an offset? Because the length is 2, but index 2 is actually the third character. So basically what this is doing in layman's terms is saying that we only care about matching a permutation of our pattern. If our pattern is 2 characters long, then we only really want to be looking at 2 characters at a time. That makes sense? So if our window is looking here, and we make it look here, we're gonna then make it look here, but we have too many characters. Shrink it. And then once that runs the first time, that's gonna run every single time until we match the pattern. So actually I would have extended this first and then done this. That's how our window's moving across the window. It's basically saying we're only gonna take a look at these chunks every single time. Okay, that's the point. That's the whole point. So that's why we need that. That's our window adjustment. We don't have a window adjustment here, not really. Well, we had. It's not really a window though. But this solution makes sense to me. Now the runtime complexity, I'm a little worried about. I mean, there is but that's n, I guess, plus whatever this is. So yeah, n plus m. However long it takes to run that one. Because they both could run the same amount. So really it'd be 2, well, no. In the worst case, they both run length n. So I don't think it's n plus m. I think it's O of n. Because 2 n length loops in the worst case is O of n. I don't know why they're saying it's n plus m. Yeah, I think it's I think O of n is fine. O of m, since you're storing it in a frequency. Yeah. Okay, so, but the rest of it makes sense, right? Managing the frequency dictionary, the tracking of the character frequency, managing, let's say, okay, well, we're going to increment it if we see it, or we're going to take away, we've seen that one, and if it's at 0, we've matched all the available B's, right? And then it's like, if matched equal to the length at any point, return true. Else, not else, but also shrink the window by 1 character if interesting how that works. Well, it would just keep going then, right? Because, so for example, let's take our BAA. Let's look. So for example, we'd say, okay, the frequency dict would look something like this, right? would look something like this. We have a dictionary. We'd have B at 1, A at 2, 3, F, 1. Our pattern is B, A, F. This is the start of our stuff here, right? We have a start. Yeah, we have a start. We have matched. We have what else? The frequency. Cool. So we first populate this. Our start is at 0, matched here. Our right character is from the string itself is a B, right? Say is B in the frequency. Yep. We loop through the pattern. Okay, this is a pattern. I'm sorry. So we're looping through our actual string. Say is B in the frequency? Yes. Subtract 1. And if it's in there, increase matched to 1. Cool. Then we say, and we're saying our window n is pointing to, I'll keep track of end here. It's now pointing to 0. Matched is not equal to length of, it's 3, right? So 1 is not equal to 3, so we're not worrying about that right now. Or 3. Cool. Next is A in the pattern. Yes. Matched. We don't increment matched. And our end is pointing to 1. Sweet. Is A in the pattern? Yes. Matched. 2. And it's not pointing to 2. Matched is 2. Greater than 3? No. Then we look at A. Is A in the window? No. A is not in the window, so we don't touch the frequency. 4 is equal to 3 though. So we've basically said, okay, so this basically says basically it's saying, does our window contain characters that are not in the pattern? That's basically what this if statement is saying. If our window n is further and is not matching up with is not matching up with the pattern, we've allowed for too many things to be in play, which is why that's okay, right? So what do we do in that case? We move our start to 1. I wonder where start's being used. But why do we bump this start at all? Because if we extend it, then we want to say the left character, which was pointing to B, so if we tried to match it, then we take match down to 1. Let me put this back up to 1. We're missing a B basically. Or, yeah, because we match with B first. Great. Okay, that's current state. Now we're index, what, 4? Which is the F. And F is not. Cool, yeah, that's false. Sweet. I mean, the solution works great, but I think it makes sense why it work, yeah. Wow. Next problem, we get 40-minute timer. Then we gotta be done. Oh my God, I hate this. that fix everything? All this goes there. That goes there. I don't know why everything's grayed out. There's some syntax. Okay. Well, that's fine. Yeah, I can deal with that, but. Oh, this. Okay. Gotcha. Gotcha. It's S. S. What else? And this is an S. Run that. Run our tests. Well, this is the true, you know. Key error. Oh, what? Key error. Oh, oops. Different problem though. No key error. My indentation's off, I think. To the for the if, that looks good. For window, and right char. Oh, this is in here. What else? Matched. If. Cool. So this is not. Oh. What? Okay. Looks like we got. What? The DC pattern. But we got true. Why do we get true? Wait, refresh this. I'm quiet because I'm trying to think, but okay. I mean, I copied the code. I don't know. True, false, true. But two of them are wrong. So insert true to false. Yeah, this should be false, but it gave me true. Why? No idea, bro. Let me just copy the function entirely and see if that does anything. Pattern of string, okay. I'm focused, that's why I'm quiet. I'm in the zone right now. But that should be everything, right? Indentation looks well. Weird. I guess my indentation was off. I don't know. I don't know where it was. Let me go back. Yeah, I mean, I had some double indents by accident. I don't know. Anyway, it works, so I'm not too worried about that. But yeah, I think we're fine. But I now understand why You need that frequency dictionary. Otherwise, okay. So what I've concluded. I mean, the point was to finish it. I just didn't. I just didn't wait to look at the problem. But let's do some analysis. There's the book says this is this is big O n plus m, but the for loop in the beginning is guaranteed to run. Oh, gotcha. It's n plus m because the first one runs for the length of pattern, which could be different from the length of string. So cool. This is big O M, right? It's a unique character in pattern. Is that accurate? If I type that up and leave it like that? Yeah. Well, really, wouldn't that be? No, because you can have repeats. And it would be a varying number of repeats. So like the number itself could be huge. Yeah, okay. Cool. All right, problem 2. This time we're gonna set a timer. It's gonna be 40. I have 40 minutes to solve the problem. And then after that, I look up the answer. All right, given a string and a pattern, find all anagrams of the pattern in the given string. Okay, let's mark down going here. Hard problem. String anagrams. Probably should have started this before the timer goes off, but it's fine. Next time we know. Statement is what? All right, here we go. Problem statement. I didn't do a explanation of this, but I should soon. Did I skip one? Oh. Okay. 38 minutes. Sweet. Given a string and a pattern, find all anagrams of the pattern in the given string. Every anagram is a permutation of a string. As we know, when we are not allowed to repeat characters while finding permutations of a string, we get n factorial permutations or anagrams of a string having n characters. These are 6 anagrams. Write a function to return the list of starting indices of the anagrams. Ooh. What? What? Okay. So the idea is to say, do I understand this? There's 2. An anagram. So PQ can start at index 1, so P and then Q, or at 2, which is Q and then P. Okay, so very similar to the last problem, except we're storing okay, yeah. Very similar to the last one. The last one taught us something. They're teaching us something new and they're giving you a problem similar to it to see if you can really apply it. So we're going to do our normal situation here. That's 6:20. That's a long time. 40 minutes. It's a long ass time to solve a problem. Now that I think about it, it might not even take me 40 minutes. I think it's going to be similar, I think. I think a frequency dict is going to be part of it. Because we're also tracking, like, there can be multiple. There could be none at all, but there could also be multiple. So if there is, I'll say that if there is no, anagram, then we'll just return an empty list. Or I guess false, I don't know. Okay, something like that. Anyway, put our function here. Okay, we create our testing code, which has a bunch of tests in here. And we say at pytest mark dot parameterize. So we have our string, our pattern, and our expected. Our tests here. We define a test function with our string, pattern, and expected. This is a list of ints. This is a string, and this is also a string. And we assert that find string anagrams when passed in s and pattern equal expected. And we'll also add our ipytest.run function. Okay, cool. So what I understand so far is that we'll need to also do the same like permutation finding, I think, solution, but I gotta understand why it's different from an anagram. Does that make sense? So this is gonna be PQ, and the expected result is 1 and 2. And then the same expected result is that, and then ABC. Okay, sweet. So if these are failing tests, as they should be. All right, let's take a look. So the last problem, we had a window start previous solution, right? We had this window start, we had this frequency character, and then also the match, this idea of matching. The idea is that once we match once, we may need to match multiple times, right? So already I'm thinking, well, we can modify the we can modify our frequency dictionary. We'll have to reset it though if we fail to make a match, because there could be other matches in the string. Last time I think there was only one match. Once you matched it, it was over, but we have to do a reset. So we can write some reset code, right, to reset char frequency, and it'll just run that for loop to reset it. Okay, so we'll look at each letter. We'll manage the frequency. If I don't know, we move our window no matter what, right? That's kind of the thing. We move our window no matter what. So for example, with this problem, right, we have P, Q. P pattern is PQ. We take a look at P. There is a P, right? If we take a look at our mapping here, we have P at 1 and Q at 1 in our character frequency. So P, we subtract a 1, cool. We're not at matched yet. So we subtract, I'll keep track of, I'll say mapped, or I'll say matched, right? Equal to 0. Our start equals 0, and then what else? Frequency is up there, cool. So we saw P, That's at 0. So our matched gets moved to 1. P at 0. Okay. We see another P. P is in it. So P is in it, which means that we're going to want to subtract another one from P. If I'm following the code right. So is that -1? Yeesh. So what does that mean exactly? But we don't increase matched. Okay, no, I mean, if I'm following the code right, yeah, that's right. Character would be P again. P is in the character frequency, but P is equal to 0. Subtract 1. And P is equal to 0, add 1 to the match. So we don't increase match. We match with the P already. Right? And match is 1. Length of frequency is... Length of our frequency is 2. That's not equal to, we're not matched at all. N is at index 1. So we're not going to shift our window at all. We look at Q. Q is in the... Okay, interesting. We didn't have this problem last time, though. Let me hold on. This get solved here. So if I had the same one here, PPQP. What is it? Yeah, PPQP, PQ. This should be true, right? Failed. Oh, this is not even the code that I'm... Wait, what? Why is that wrong? Okay, what? Wait. Oh, my other failing test. Okay, so sorry. Woo. Okay. This runs, IPyTest runs tests in the entire thing. So we could run it clean, I guess, before that, but let's say, I mean, cleaning doesn't, what was the, delete doesn't names matching the test given pattern. Oh. Interesting. Let's clean tests. Give it a pattern. It's kind of weird. Anyway, yes, R2. Oh, so running clean. Okay, got you. So these 6 tests passed. How? How do these pass? I'm not exactly sure how these pass. Well, I mean, we never match, right? We never really match. So our window, once we get to the second queue, technically speaking, matched still isn't, So once we get to Q, hold on. Right? Because we already matched with 1 P. We got another P. So we give it a -1. But we didn't increase match again. And then we said window N greater than, -1. So once we hit the second Q, or the first Q, but index 2, 2 is greater than or equal to, I missed some code. Okay, start over again. 26 minutes. Okay. Yeah, I missed one code before. Okay, so the last problem we did, it creates urgency to do the timer. It creates urgency, I like it. Oh, look. The sun has risen. It's good. Um, okay. Start at P. P is in it. Match gets 1. P goes on to 0. Match is not equal to 2. And 1 is equal to length of pattern. Interesting. The length of this is 2 minus S1. Therefore, we say the start gets bumped to 1 if left character, so if P in it, if P, so 1 is greater than or equal to 1. Really? We're moving it already? I thought it was more like if we have 3. No, if we already have 2, bump everything because you're about to add another one. Does that make sense? So if left character so is 0, okay. So we bump this back. We first actually bump match down to 0 because we're taking a P out, and then we're bumping this up to 1 again because we're moving. Yeah, the code all makes sense. It's kind of crazy how it's all being used. Kind of weird, but it's cool. So now our start points to the second P. So the reason why they moved it, because if it was, yeah, I mean, once you match, even if they move the pattern, you're gonna hit match and return true before you even run any of this code down here. So in the next iteration, you'll see that. So P is in it, we match, so 1, that goes down to 0, okay. Match is still equal to 1, which is not equal to 2. 1 is, right? Okay. Our left is pointing to P. So PQ is there. This is so interesting. So P, wait. How, what? Wait, what? What? So right character is pointing to P. I got you. I messed up. Okay. So start was at 0. Sorry. Start again. P. I was about to say, when does the window expand? Yes. Got you. Okay. I thought start was at 1. I don't know why my start was at 1. It's at 0 for the first P. Okay. Yeah, so P is in there, match gets 1, P goes on to 0. Match is not equal to this. Window end is at 0. So we need to have at least 2, right, to be able to have that. Okay, got you. Which is what, and so understanding the problem helps you catch your own mistakes. Which is next to impossible to understand the problem. So, cool. We add another P. P we put at -1 because it's in the frequency, right? We don't move match because it's not equal to 0. It's actually less than that. But we don't check for less than. Match is still 1. Forget that. So we're at the end is pointing now to index 1, which is equal to length of pattern 2 minus 1, which is 1. Therefore, we then bump our start up to 1. And then we take the left character. Before we bump our start, the left character is a P. And we say, if P in the character frequency, okay, and it's equal to 0, then If it's equal to 0, that means that we only had one P, or one of it. If there's multiple of it, then we would have subtracted it multiple times, and you want to bump it. You want to reflect how many P's there are available left to match, right? So there were 2 P's, which is why it has -1. We bump it up. We don't move matched because we still have a 1. Wow, that's crazy how that just all works out. We take a look at P, 0, matched 2, done. Matched equals 2. We've matched it. Okay? So how does this work for it's for anagrams, right? Let's take a look at, okay, so the point is to then create this array of starting indices where we have a match. So we use the same tactic of a frequency counter. We use the same matched idea. Our start is at 0, matched 0, starting at P. We'd have this return array, right? And we'd say what? We'd say, okay, is P in the frequency? Yes. We want to find the anagram though. So the matched goes up to 1, P goes down to 0. That's perfectly fine. Okay. Match is not equal to the length of the pattern, so we don't do anything. But I'll write down a new, we'll figure that out. We'll get to that part. Start is not greater than or equal to 1, so 0. We don't touch anything else. We have another P. Okay. P is already in there, but it's not equal to 0, so we don't touch matched. Given that we're now at end 1, we have to shift everything over once. So we move matched. Match is still 1. P is not back to 0. Start now points to 1. Sweet. Q is in it, so therefore we turn that to 0. So in this case, matched is now 2, and we have the condition. So matched equal length of pattern when we found an anagram. Therefore, we should add to our return the start of that anagram. So I'll say append start. Okay? We don't want to end the problem there. So what happens when we find a start? Well, in this case, we want to just append it. And in this case, we want to restart, I guess, reset match as well. I think. Our start still points to 1. And if we just replace that bit of that if statement, the 20, 21 through 20, or 20 through 21, we'll go to the next piece of code. Start is still at 1. So we're gonna adjust, we're still searching, we're gonna adjust our window again. So we're going to move the start up to 2, but first we're going to store the P, and then we'll say is P still in it? Yes, it's equal to 0. So match goes down. So we don't have to adjust matched here, because we're gonna start the search over again. But we do want to increase, because we're gonna lose that P. So our start is still pointing to the other Q. Okay. Our start is now pointing to Q, but we're not at Q yet. Does that make sense? We're not back up at Q, but we are. The loop runs like a loop. I'm thinking into the loop, out of the loop. We're moving that up. Okay. Then we're saying frequency equal to 0. We're saying turn down matched. Don't. We're gonna reset matched anyway. Do we have to reset matched? I mean, we'll find out. I'm not sure we have to reset it entirely, but we might say like, well, this technically will take care of that for us. Yeah, let's not do that. Let's see what happens if we don't do that. Let's see what happens. So we're gonna go in and we're gonna increment P because we're losing it. Match is now 1 because we had a match where that's Q. And we're saying, okay, cool. So now that's everything, right? That's everything. Yeah, that's it. Okay. So start now points to the Q. Is Q in here? Yes. Okay, here's what I was thinking. We have to run some code that resets our, but the reset's tough because you want to start again. You'd want to start again from P or from Q, right? So we'd say, okay, Q, this end is 2. Okay. We'd say, is Q in it? Yes. That means it would give us a -1. We wouldn't increment matched. Matched is still 1, so we're not going to do any appending. We're going to say, is 2 greater than or equal to 1? Yes. What does that mean? That means we store the Q. We say in our start to point to 3. Okay. We say, is Q in it? Yes. Equal to 0? No. But give it back up to 0. So we matched the Q already. Is P, okay, that's everything we had to do, right? Okay, is P in there? Yes. Subtract, matched. Okay, wrong. Because we're going to append start. That would be 3. It wouldn't start at 3. It would not start at 3. So what was the issue there? We moved the start up. The start moved under the wrong conditions. I only have 15 minutes left. The start moved under the wrong conditions. The start moved up anyway because our end was pointing to something greater than the length, -1. So our start is at 2 still. And we really only want to move the start if we deem that this like works, right? I mean, if we moved it here, right? We just bumped the start up for no reason. Not for no reason, but we bumped the start up anyway, which because it could be PQ, QP, PQ. So we really only want to bump the start when we have appended, when we've added something to the list. No, dead ass. Well, do we want to bump that up now? Because technically, so let's say we go back, right? Our start's pointing to the P, index 1. Because in the last situation, well, no. Matches 1. P is at 0. Q is at 1. Start is at 0 still. Okay. And we're saying we found the second P, so start gets bumped up. P would get bumped back to 0. Start gets bumped up to 1. That's it. Okay. Then we add the Q. That gets taken down. Okay. And since match is equal to 2, in that case, our start gets bumped to the next one. And which means matched gets bump down one as well. That's window management, right? Do we have to worry about the other ones? Yeah, we'll have to also manage the frequency as well. So we'd have to, before we bump up start, we'd have to store our starting character. So left gets, S at start, which would be 1 in this case. So that'd be P. Then we bump up start. We'd adjust the matched. Then we'd say if left in frequency and left of the frequency equal to 0, then take that and bump that up because we're taking out a 1. This is all in the if matched. We're kind of taking some of the code from here, and so then this would get a 1. Okay, let's keep moving. That's all we do. Take a look at Q. Oh, that means we bumped up the P again. Or we did that already. Did we? Yeah, because we took out a 1. So we bumped it back up to 0. And Q is still at 1. So we see a Q, it matches, match gets put to 2. Oh, so we just did that. That's what we just did. So then match gets bumped. Huh? Let's start over again. New code, but let's start over again. I lost my track here. 1 1 matched 0 start 0. We see a P, subtract 1 from the frequency. Match gets put to 1. Match not equal to length. We don't do anything else. We see another P. It's in it, but it's not equal to 0 anymore. We don't move matched either. Okay. We see a Q. Match gets put to 2. Great, we matched. So append a 0. Okay. That's also wrong. We don't want to append the start. So we don't want to append the start right away because okay, so let's not append the start yet, right? Let's say we skip that line. We take our P, we bump the start up to 1, we put match down to 1. Then what? We bump up our P to 0, and then add the 1. Let's move this down here. Okay. So our start at points to 1. Great. So we add another. That was the Q. We see another P, minus 1. P is not equal to 0. What? Yeah, P is not equal to 0, so we don't even pump match, which means we don't add the 2. Let's run it again. I have 7 minutes. Yeah, the timer is great. It limits how long I spend on a problem. It's great. 1 1. Okay. So we start with this. P is a match. 0, 1. P is also a match. Minus 1. Q is a match. 2, 0. Right? We store the P. Bump up our start to 1. Our match goes down to 1. and we say if, so P, because we've seen two of them, so we have to just bump up the left anyway. Which left is in it, so we just bump it up back to 0. Okay? And then we append the 1. That's because we have a Q. Then we add another P. P goes back down to -1. P is not equal to 0, so we don't increment matched. And that's where we have a problem. So using this exactly as we have before is not going to work. I'm trying to figure out how examples can help us solve the problem. Damn it. Let's try a different case. I didn't solve this case yet. I'm trying to think. I don't know. There's an idea of a match still. Like, how do we track that we found the permutation? Yes. But updating the frequency is important. Huh. Very, very, very interesting. I don't know. We're 4 minutes in. I don't know. We're 35 minutes, 36 minutes in. I'm not sure. I try to use the same format. We got close, but for some, with the same one, we don't match doesn't get updated at the right time. I mean, okay, so let's try to step through it. I'm trying to use this match idea, but let's try to step through it. Right, because we can use a similar format, but there's going to be a couple of adjustments. I think the frequency makes sense to use because we're still doing the same kind of work. Right, and we're gonna want to know when we found a permutation. The question is, how do we properly adjust our window and add our index to the list? That's what I'm worrying about. So let's say I see a P, the next one's a P. That's not valid, right? We say, okay, we have another P, we have a Q. That's valid. We want to add start. So something about incrementing start. So I mean, I would like to move the start there, but you know what? The next one's a P. Therefore, we already saw a P. So maybe we just throw away that whole sequence. Or maybe we say, okay, we subtract the 1, we increment matched. I see another P, that's a -1, right? But maybe I don't do that. But I say, well, we still have 1, just move your start. All right, then you see a Q, matches 2, start points to 1. Do we move the start again? If we move the start again, then we'll need to also do one of these. But we'll have to do the upgrade before that. So we're looking for a P. And we'll also do this. If the next one is in it. Right? So if left, or I'll say left, if right, in frequency, So if the right is free, if the right is in it, we want to update matched, or we want to decrement at right 1. If it's, I mean, then just do matched anyway. But only do matched. What did I do before? I said before I was like matched at 0, start at 0. You know, we're at 1 here. I said P, it's in, so match it. I said so P is in it. If we've already seen it before, this is no longer valid. So if it's in it, right? If in it, then we say, okay, if right, if the right is already equal to 0, then bump up the start. But we want to bump up our start. Okay? Because in this case, is that always the case? Probably not. But more test cases should. I'm close. I'm close. I don't want to stop. I spent too much time. Yeah, if you give me like. Fuck. It's fine. It's okay. 40 minutes, man. It just helps us move through the problems. If you take too much time to move through them, we'll sit here forever. Okay. The point is we just can't sit forever. But I think I'm close. Let's see if I was close. Next time I think we'll keep it, but let's see if I was close. So given a string, blah blah blah, solution. So it's similar. We need to find every occurrence of any permutation in the string. We'll use a list to store the starting indices of the anagrams. Sweet. And they only changed a couple of lines. They added 3 lines of code. What? Okay, why did when I tried that, did it not work? Huh. That's crazy. It was so similar. I was like, yeah, but we might need to, I don't know why. Why did I think about the reset? I don't know why I thought about the reset. I didn't even end up using the reset. That's crazy. That is so crazy. They added 3 lines of code. 3 lines of code. God, that's a little bit frustrating, not gonna lie to you. But it's fine. We give it our best shot. I mean, granted, we give it our best shot. That's all that matters, bro. I just want the code. Huh? Oh. Yeah, makes sense. That's right, that's right, that's right. And then what else? They changed 3 lines of code. Just crazy. So crazy, man. I thought it would be similar difficulty. I didn't understand exactly, you know. Crazy. Oh, they failed. Why? Return back 0. Ooh. You know what? Copy the whole damn function because apparently there's something wrong in here. String pattern, string pattern. Yeah, that's right. Can I put some arcs in here? No, Dash V did not do anything, by the way. Crazy. It's S and it's pattern. You know what? As I said. Wasn't it so messed up? Oh. This stuff was too far forward. Hold on. There we go. Yup. Yup. Right, that's fine, that's fine. If match, that's fine. I think I just have it wrong. Yeah, I just have it wrong. The solution doesn't work. Or what is it? I said string pattern. Because it is P, P, Q, P, P. Am I insane? I think I'm insane. Assert that list of 0. Huh. I mean, indentation shouldn't matter that much, but something's wrong with the test. Frick. What could possibly be wrong with this? Let's run this right quick. It's returning zeros, I'm not sure why. I mean, this is kind of weird, but... Okay, yeah. Interesting. Well, it depends zero. So when do we get in here? We get in there twice. Yeah. Oh, I thought that was wrong. I'm not sure how they're getting the 1 and 2. And I literally copied the code. I mean, indentation's a little weird, but it's not. That shouldn't be fucking with it this much. I'm just trying to figure out what I did wrong. Yeah, we know A greater than F star. Like, I mean, the code is the same, but it's not being appended to. Crazy. Yeah, and it's just printing zeros. This Windows start never gets touched, I guess. Yeah, it's adding Windows start. It matched the length. Window end is its own loop. Ah, got you. Not under this if. What? Oh. Okay. The indentation matters so much in Python. Oh my god. I was like, don't do this to me, man. Hey. Cool. Crazy. Am I gonna stop there? I don't know. It's 8:30. I have a lot to do. Some emails from Ross. So it said this is a full-time role and still fresh in the market. This may get covered till then. You need to lay off at multiple big clients. The situation is tricky right now. Yeah, that's why I'm off the market, Ross. Because I don't want to get laid off. Said it might be, what do you say? So it's fresh in the market, and it may get covered. I wonder what covered means. Maybe it's saying make it filled like this year, early next year. And due to I'm not in the market right now. Am I nuts? So it may get covered till then. And due to layoffs, it's tricky right now. Still not interested, buddy. Python REST APIs, done that before. Dribble, Uber. I kind of missed the bond touch a little bit, not gonna lie. Cool. Cool. I have a class I need to look at. It's on Udemy. I think it's on Udemy. I'm not sure. But wow, app's open. Shipped. It's on the way. What does that mean? Estimated date today. Oh. Okay. As in it's like right next to me. That's crazy. I'll get my card and stuff. I can use Shipped and Instacart now. So what should I make? What I can make? Supposed to be big earnings tonight and tomorrow. So I wonder what the peak time is though. I wonder what the time to do. I'm probably in the evening, right? Probably in the evening. But anyway. And then shipped is, I need my card to activate my account. Did I take a photo? I think I chose a photo. Like a weird one. Anyway. Yeah. Sweet. All right, well, I'll do one more. Until what? 9:10? 9:15ish. I need chap. There's one line of code. The change was 3 lines of code. How? I mean, yeah, but how? I said it would be similar. So some of the basic stuff I thought we would keep, and I knew that we were gonna append it. But for some reason, when I walked through the code myself, I got a different result with the window, and I didn't really like it. What did I get? Hold on, let me walk. I'm walking through this because I don't. What? I mean, it works. I need to understand why. That's my whole thing. I don't doubt that it works. I doubt that I understand why it works though. That's kind of my thing right now. Okay, so with the first one, window start is at 0, frequency is filled, matched 0. We see a P, so that's now 0 in the frequency. Match is now 1. Match is not equal to 2. Okay, and our window end at 0 is not greater than 1. Cool. We see our second P, it's in there. So it goes down to -1, but it's not at 0, so we don't increment matched. Match is still at 1. Our window end is now at 1. We now bump up the start to 1. Okay, so that second P already gives us the right starting index, correct? And then since it wasn't at 0, we bump it back to 0. Okay, is Q in there? Yes. Match is 2. Q back at 0. We add our 1 to the index. The end is now at 2 greater than 1, therefore we have to bump everything forward. So at our start, the left was at P, so we have to subtract matched. Okay, we're looking for a P. We see a P, 2, 0. We had 2. Crazy, but okay. What did I do before? I don't understand what I did before. I don't know what I was doing before. I'll watch it back when I upload this because that was weird. Anyway, time analysis, NM again. Storage is I guess N because it could be all anagrams, right? Is that right? O of M. The whole pattern must have distinct. Yeah, there's two storages, but they're not related to each other, but I think they're just there. I'm not sure. We're saying big O N plus M. And we're saying space. I mean, it's not shared space, right? But it's it's N for the. Well, I'll say M. Well, N for result lists, and we go M for the frequency detect. Okay. That's that on that. All right, next one, the timer, 40 minutes. 40 minutes. Let me get myself set up before I do the next one. This is another hard, they're all just hard problems. Why are they all just hard problems? Ugh, can I get a easy one? I mean, ideally the hard ones are easy once you get good at there. All right, so am I doing, the explanations are cool because they're in English terms, but I don't know, I think the code should be a good explanation. The code should say what you're doing, I guess. I might go back and do the explanation again like I used to. It's fine though, I'm not too worried about it. I did not try solving this at all. It's perfectly fine with me. Let's add our tests. At PyTest with the string pattern expected. Test will match that. Define a test. Test find substring. With the string 1, string pattern, which is a string, and a string, okay. And we'll assert that find with the string 1 and the pattern equal expected. I probably could do something like this. PyTest.run. Yeah, that's it. Let's do it. Let's take a look. So these problems are supposed to build on each other. The idea is that you continually look at these problems and they build on each other's solutions. So in the last problem, we had a similar, I say window management, but yeah, window management. This idea of matching. Let's read the problem statement. So what's going on? So given a string and a pattern, find the smallest substring in a given string, such that which has all the character occurrences of the given pattern. Now we had a problem similar to this where we were looking for what? I'm looking for something similar to this. Some smallest problem. Something small. What was it? I guess not. I guess that was a small subarray problem. Find the smallest subarray with that sum. But now we're doing pattern matching. Interesting. So we're kind of combining, we may be combining the smallest subarray with. Anyway, let's take a look at our. Okay. I'm erasing all that. I'm not sure we need a dictionary either. Let's just start from scratch. Okay. So A, B, D, E. C, pattern is A, B, C. We're looking for the smallest substring containing these characters. Okay. So this is different. The answer would be, A. Oh, we're looking for A, B, C. A, B, D, E, C contains A, B, C. And we're going to return the string that matches that. Okay. So, So we're looking at each character and we're asking if it's in, but we only want one though, it seems like, right? So, we're looking for A, B, A, C. Okay, so this gives me the frequency count vibes, which means that I have to keep track of the fact that there's A. In our pattern, there's two A's, right? A B and a C. And if I'm looking at A, B, D, E, C, I'd say something like, okay, if I'm looking for A, B, what? I'd see an A, great. It's already in our pattern, so I guess subtract the 1 if we do the same thing as last time. Do we add this to our output? Potentially. We can always reset it later, I guess. And our start, I guess, points to here. Our end is at A. Our matched, equals 1, I guess. We see another A. Match 2. We see a B. Match 3. A D is not in it. Okay, a D is not in it, so we don't really care. And the output can be any length as long as it's containing those things. So I wonder when we adjust the window here. What else? What else? What else? What else? So D didn't match. E doesn't match. C matches. So why do we lose output? Well, our matched is equal to the length of our pattern. That's one thing, right? So if at any point, okay, but there's no like length restriction, right? Our window could essentially get to n or index n minus 1. We could have n minus 1 characters or n characters in our window and our windows, you know what I'm saying? So we're going to have to keep expanding our window until we see at least 4 characters, right? So if we have 4 or more, I don't even to check. It's like if we have four or more, I don't know. But okay, in the last problem though, we had we're searching a substring. We're saying, if match hits, do something with that. But our window adjustment looks different, right? We're saying that if we are longer than the pattern, we want to shrink something. Correct? Let's see a different example and see if that makes any sense. So let's look at A, B, C. These are the same style from the last one, frequency counter, matched idea. 1, 1, 1. So we see in A, our match goes to 1, and A goes down to 0. We see another A, right? Which means that this already is invalid, right? We can't have more than that. So maybe we do our match back down to 0 and put our A back, and our start now points to second A. All right, then we see our B. We don't move it up. We don't move it back up because it wasn't, or we automatically subtract to -1, and then we move it back up to 0. And then we see our B. We don't see a C for a while. So we have no reason. The only reason we would move the startup is if we see one too many. So similar to this, if our window end is at, but so what are the conditions? Well, the condition here was that our A, our start character, we saw too much of. If we see too many B's, so can we not have too many B's? B, C, A. So we wouldn't have the A, B, D, C. Yeah, we want that exact substring to be contained within it. We want the smallest substring. Technically, A, B, D, B, C contains an A, a B, and a C, but it's not the smallest substring. Okay. So in this example, back to the A, B, C pattern with A, B, D, E, C. B is in there, D is not, E is not, and C is not, or C is, rather. So match goes up to 3. Was that 2 before? 3. And we're at 0. Now, the reason why we'd even return this whole string is because it's an exact match, right? Because we had all zeros. Let's go take a look at another pattern, right? The one that looks fishier. Let's do the A. This one looks kind of cool, like this one. What's the pattern, ABC? So the string is, right? So it's A, B, C for pattern. Our match is at, what's it called? 0. So we're looping over the array. I'll just write some pseudocode here for, I'll say C in, I say try, it's not bad. I'll do S in string 1. Let in string 1. We're looping over this, okay? And we're saying that if letter is in it, subtract it from the frequency. So if, for letter, storing the variable to if, right, which is equal to let, we'll do an index here. If right in the frequency, subtract it. So then do frequency at right minus equals 1. If equal to 0, and do match plus 1. Matched it. Sweet. Returning a substring. We're going to have to keep track of letters that appropriately match, I guess. So, I mean, we'll keep track of it somewhere else. So we're adding A to it. Is B in there? Yes. Match is 2. B is at 0 now. Got a B. Is D in there? No. So I think it's touched. D is not in it, but it can still be valid, part of the shortest one. B is also in it again. Okay. We have a problem, right? Can't have more than one B. We're looking for A, B, C, some combination. We're looking for some combination in a substring. And the smallest one. So having a repeat probably isn't the smallest one. So what do we do in that case? Well, we didn't move matched because it wasn't equal to 0. But we did subtract automatically from this. And our start is pointing to this A, I guess. I don't really see it. I don't really see a need for a start right now. So we technically matched it, right? Technically this match went up to 3. We need a way to bring this back down though. Okay, so does that... I didn't even start the fucking timer. Okay, I have like 20 minutes left. 20 minutes? I think it's 25, or is it? Where are we going? 9. I'll say 20. 20 minutes. Frick. Yeah. And this one, the window start was mattered. And here, the window start was what? I mean, we tracked it, but we had to keep track of which character to remove. So we're taking the A away. So we could try that, right? We could try taking the A away, and we'd increment this back up to what? 1, and our match back down to 2. Technically, for a second there, match went to 3. No, it didn't. Match was always at 2. Yeah, match was still at 2. So we never did anything with like if match equal to blah, blah, blah. So our start gets bumped. Now we're starting at B. B, D, B, right? So what triggered that? Well, because technically, okay, so we saw another one. Frick. But the point is, we've seen one too many characters, right? This B is the start. We know that's the start of our next one, right? So we kind of want to get down to that. We know that the B is the start of our next one, but I'm not exactly sure. If we follow this one to a T, then what happens? If we follow it to a T, what happens? Match was at 2, bumped up our window to A. Why did we bump it? Because that's what this one would have done. Okay. We bumped it. Now we're pointing to B. We have B, D, and B was in it, right? But we only want to add it if it's a valid match. Correct? So we didn't add that B. Okay. So we have B and D. We're looking for a C and an A. I'm assuming that in the move, we moved our start, we bumped our B back up to 0. Even that looks kind of weird though, right? Well, let's continue walking through it. So we saw the other B, we decremented the B back down to negative, then we moved. Okay, so we'd want to add A back up to 1, and this B would still be at -1 technically. So as we come back into the loop, well, what? Okay, what moved it? Hold on. Right, what moved it? So we have an A, that's a match, 0. We have a B, that's a match, 0. We have a D, not a match to anything here, but can still be part of a valid substring. Match is currently at 2 because of AB. D doesn't move it. Then we see another B. So we would automatically move this down to a -1. Okay. Match is still at 2. What's our adjustment? Well, our window, we're moving. We want to move our window because we've seen too many B's. Okay, so we could take the A out, I guess. So we follow this exact example like I did before. We take the A out, bump it up, move that, since A was at 0, and bump it up. And our start now points to the first B. We haven't touched the other B. Cool. We see a C. We now have B, D, B, C. Not valid at all, but the match is at 2. Cool. What's our end at? Our end is at, oh, the conditions were end. Oh, I should have moved that shit a while ago. Well, no. This is index, what, 3? At 2, at finding the other D, I should have moved it. Yeah. Yeah, let's start over. Yeah, I should have moved it at the other D. Hold on. Okay. Match 0. You have an A. Right? Okay, let's start over again. So start now points to A. Our matched is at 1. Our matched is at, yeah, matched 1, start 0. We bump this down to 0. The idea is that match is equal to something. We do something when we find a match. So I guess we're appending A to some return string, maybe. We're doing a join of some sort. Might use a queue or something to keep track of like things that are current. Might use a queue actually, by the way. Okay, what's going on? Yeah. Okay. Next we have a B, 0, matched to, we're gonna move our window because index 1 is greater than or equal to, no, we won't. That's fine. Is that 3? Sweet. What else? Is that it? Yeah, that's it. Okay, we see a D. Doesn't match anything. So we currently have A, B, and D in there in the mix. We have A, B, and D in the mix. End is now. Okay, so in the last one, our end currently is at index 2, which is greater than or equal to 3 minus 1, which is 2. So that This would be cause to move our window. This would be cause now to move our window. So if we did that, we point to 1. We'd bump out the A and point down to D. Okay, we'd also increment this and subtract from the matched. So we'd add that character back. Okay, 1 match now. We have a D. D goes on the -1. It's not equal to 0, so we don't increment our matched. Match is still at 1. Technically index 4. Now the thing about it is that, so in this example, if we follow this, it's gonna match perfectly fine. For the ones that are greater than this, we don't want to adjust our window just because the end is there. We want to adjust our window under different conditions, right? So my girlfriend just texted me about my car got hit. I got into a car accident yesterday, and my car just looks perfectly fine, so I just drive away. That's fine. That could have been a mistake, I don't know. But, anyway. Yeah, so we discovered that these conditions don't really make any sense, right? Because it's valid. This could be valid up until a certain point. We know that once we add another B, we don't want to keep this because it's not valid anymore. But we need to adjust our window now. So I guess if we added, where am I? I mean, yeah, we'd adjust it because the index would be what? This is 3. So we'd say, okay, add 1 back. Right, we now have DB. Matched is still 1 because it wasn't equal to 0. And now we're pointing to next 2. Right? We have D, B, C, A. Now we see C. 0 matched is 2. And so I stopped because I was like, well, but that means in this example, as I already said, wow, I'm looping back over again. As I already said, yes, in this example, this code works. Now let's use another one to figure out why it doesn't work. Okay. The pattern is ABC, A, B, A, C. So there's 2 A's, a B, and a C. Our string is A, B, D, E, C. Okay. Matched 0. Start points to 0. Okay. We're supposed to keep track of some string somewhere. I'm supposed to keep track of some string at some point. Okay, we have A, valid, matched, 1. We have our A, we'll restore that, valid. We have another A, oh, cool, not a problem. 0, match, cool. We have a B, boring example. Okay, so because we saw nothing, if we saw another A or another B, what, in English terms, what do we need to do with that? That becomes invalid, right? And there can be other ones that are also valid, but the smallest one is what we want to return. So let's focus on why another A or B would make this invalid. So if I, for example, add another A here, right? This problem already becomes like there is nothing here. But let's say I add another A at the end, or, well, no, let's see. So I said A, A, B, B, E, C. Well, that's still valid. Let's say I add another, well, I don't know. I'm trying to figure out how to make this invalid, or how to make it, what's it called? B, C, I could put it, right? The shortest one is CBA. CBAA. That's the shortest one with the right permutation, the right substring. So we need this frequency counter to keep track of how many we've seen. And then we're looking at, trying to think, what's the condition for adjusting our window? Well, the condition is that, in plain English, if we've already found all of our B's and we see another B, then we know that this substring is invalid. Right? So for example, if we just walk through the code, the substring is invalid because we've already seen this variable before. So let's say I saw another B somewhere. So we just had let's say we just had A, B, B, E, C. Right? Technically, this is not valid. So if I had an A out, B out, if I saw another B, I'd be saying, okay, this character that we're adding has already been found. So I'd say, okay, since B is equal to 0, everything before it is invalid. Damn it. But I did that before too, and that wasn't even that wasn't really valid though. I'm not sure. I'm kind of giving up, I don't know. Because using our last example, it was, Using our last example, we kind of shifted everything over just because we couldn't have more than M letters in our window. We can have any number as long as it's the shortest one. So how do we, what's the conditions for adjusting the window so we have the shortest one? I think the code about reducing from the frequency dictionary, and doing match is fine. I'm thinking just for a second, the conditions are that if we've matched everything in this, that's cool. There could be another and smaller substring in here. So I made this a valid one, right? There's two potential answers. One of them is exactly BAAC. One of them is AABDEC. Right? So why would we go with the other one over the other one? Well, it's shorter. Okay, how do we get a shorter one? Technically it's our start and end, right? Technically it's our start and end. Okay, so let's say we had A, B, D, E, C. Everything would be zeroed out. If the next character, right? If the next character that we see, after we've gotten a valid string, if the next character that we see is also valid, before we wipe away the other one, we would need to validate that there is another like valid substring after that, and that it's shorter, right? So our window start and end tell us the length of our substring. So we really just have to keep track of that length, or maybe like we could track like the smallest. We're looking for basically the smallest distance between our start and end. That's our substring. So okay, let's, for example, right, we go through A, we take away, we go through A, take away, that's A found. We look at B found, D, E, C found, right? And we can use our match to say, okay, we matched all four, right? Which means we might store in our end and like start tracking that our start was at 0 and our end was at 0, 1, 2, 3, 4, 5. Perfectly legit. Okay, that's a 1, 2, 3, 4, 5. That's a 1, 2, 3, 4. That's a 6 character. What was the smallest one? It was about to end in a second too. Fuck. This one I'm gonna continue working until I have to go to work. But I think I know how to do this. I know how to do it. I just need to figure it out. Okay, so we matched on 4. This is a valid thing we can store. So if matched, right? We could say what? We could say give us so if matched equal what? Length of the pattern. Then we say our start. That's annoying, by the way. If our start pointer, give us the min. Min? Really, we're saying if we got the match, then we want to figure out, is this a smaller substring? Okay. So we want to say if we got the match, update the start and end if the distance is smaller, right? So if our current start and end, so the pointers are 0, 0. Well, that's kind of dumb. Well, it's infinity minus infinity, right? So we'll start it out at infinity, infinity. Right, infinity, infinity. If we match, then we say if our current start pointer, or I'll say end pointer minus our start pointer is, if our current one, if the difference is greater than the one we have now, then we want to update. Gets our end, start, PTR gets our start. Is that making sense? Okay, is that making sense? So, and we could update a string tracker somewhere and be like, okay, cool, then update the string with dot join of this list slice, right? The string slice. That's not complicated to do, right? So I'll just add that here. I'll say like our return gets a, dot join of our string from our current end, our start pointer, to our end pointer, okay? That's our return, okay? That's a valid, right? Because our match got to 4, so we're doing this. After the fact, what do we do? What are the reasons? So what now? I mean, we looked at this now. We have all zeros. What information? What's the snapshot of the code right now? So they got updated. I wouldn't even track it, but you have to find a way to compare other ones. So our start was at 0, ending was at 5. Okay. Would you want to reset the count? Right? You want to reset the count? We could. We could do a reset and update our. No, because we would just find that shorter one. There couldn't be a shorter one within it. We would just find that. It wouldn't be like maybe we want the shortest one possible. So the short one could even be contained within the bigger one. No, well yeah, that we'll test for that too. But in this case, so how do we do any kind of adjustment of the window here? Do we subtract or I think we should do a reset. And then we then just say okay cool, and now we're looking for this again. 2 A's, a B, and a C. Reset to 0. Right? And if we never match it again, that's a return. But if we do match it, right, we'll do our math. Match doesn't get to 4 until the end of the loop. Then we'll say what's our, so we have 5 minus 0. Yeah, 5 minus 0. Is that greater than what? This is 1. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that greater than 9 minus 4? Well, yes. 9 minus 4? Huh? No, 9 minus 6. 0, 1, 2, 3, 4, 5. This is 6. So 9, that'd be 9, it'd be comparison between 5 minus 0 greater than 9 minus 6. 3. So then our string goes from, so basically we're whenever we find a match, so let's try a different list, right? Let's see what we're gonna do now. Let's try a different one. Let's do another one. Let's do the other one that we did before. We'll do the first one too, doesn't matter. So we'll do ABC. And we'll do A, B, D, E, C. Okay? So yeah, we're looking for an A, a B, and a C. One each. So we see an A. C and A, match goes to 1, 0. Okay, this is great. Technically speaking, A, B, D, E, C is our answer. So what are the conditions for moving our start? Because it might not be after, it won't be within though. I say within, it won't be within. Right? There's something about seeing one too many. I think test cases build your code up. So for example, adding another test case is going to help us come up with a better solution. So I think that this seems to work for now. What are the conditions? And if we use the same thing, it's window end, but it's not really window end. Right, we're not thinking about, the end of our window is past a certain, it's more like we've seen this letter before. Right, we've seen this letter before. So what does that mean? That means that anything before this is invalid. And we need to bump our start automatically. Without even checking about matched, bump our start. Or we really just want to do the same thing. We want to do something like this. So instead of subtracting, we'd say, okay, bump the start. Since match is at 1, not equal to the length, we'd have other code that says, okay, if what? If what, if what, if what? So if our new character, which matched already, fine, we have another match. I don't know why I'm standing up. I'm on camera and I'm standing up. If our new character, which already we found a match for, is, but we didn't finish. Fuck. Wouldn't we want to exit? Well, we want the shortest one, so it won't update on shorter, right? So our max didn't even hit, which means we're not done yet. And this new character we want to add has already been found. At that point, I'd probably want to write some code that moves beyond this possible solution. So I might say, if right equal 0. Well, our code would have already decremented this, right? So let's say if right less than 0. That's fast as fuck. Oh, she looked at 7, right? 2.5 hour flight. So if our right is less than 0, that means we found something we don't really want. So we store the right in a variable, and we increment our start, and we bump up the right back to 0. Okay. That makes sense. And there might be something about matched. Match was at 1 and still at 1. Yeah, so it's the same code, except our, what's it called? We have a tracker for the end and start. Okay, let's try and code that up. I mean, I'm gonna code it, I want to run it against the test cases, but I think I should run through it here. I wouldn't want to just code it up. Yeah, I shouldn't do that. But yeah, so let's see. Is that right? So and then if, right, well, we want to bump it up first. So we'll say if right. Okay, so here they were saying if the character is even in the frequency, and it's currently equal to 0, then we're shrinking the window because we've already seen this character. We can't look at it twice. So we're gonna say if right in frequency, and if right equals 0, then matched plus, or match, I guess, minus equals 1, and then right, I guess, outside the loop. Right plus equals 1. That's our solution right there. Ideally. So the only piece of code that changes is not much. Excuse me. Why does it always copy wrong? I'm kind of mad about this. Like, why does it copy wrong all the time? So annoying. Right? Electricity. I feel good. Ish. Feels good-ish. pull up the other one again. I messed up somewhere. Something with the if statements not being properly. I need to change how that thing copies, but I actually need to go to work. Hold on. What's today? Day? Okay, sprint planning in 4 minutes. Ruby's already in-house. Lynn, UI, functionality, questions and answers. Would be a good idea to take these questions and answers. Whoa. Merge. Added low table merge. Sprint planning. Oh. So is it shortened or what? I don't understand. No, I think she just has to leave at 11. Or whatever time that is. But yeah. Oh, we have another meeting today. Frick. Frick. Fricky frick. I have 2 minutes. I'll just do this now. Okay. What's I doing? I'm trying to figure out why this is being weird. Okay. So our code was saying that we would have also a start pointer and end pointer that would be updated. And we say if matched, we say if end pointer minus start pointer, if the difference is greater than our current end minus start, which I might need to actually update this. Now return would be what? It's a string. We'd say end pointer gets end, start pointer gets window start, and Brett gets dot join on the string from window end to window start. That's what we're gonna use for, oh, probably backwards, right? Well, no, I'll just say start to end. I need to move this over. Return ret. Let it. Pretty much. I can join this without having this. My mic might go dead. I'll just pick this up tomorrow. It's fine.